Okay, dear friends, we are into the next two topics together. We will see so that we understand the difference between the two. This is shortest path and minimal spanning tree. Let's imagine the two are, of course, with a related graph that is directed and weighted. So here we have a directed weighted graph. Direction means the edges have got order and weighted edges are having weighted. Let this be the distance. Now if this is a graph that has got 5 nodes and connected and showing the distance. Now what is a shortest path? Of course, the shortest path is always from a starting node. Any node can be anywhere. For example, if I take the starting node A, this is S starting, and maybe a destination node T can be any node, but let me take E. So A to E, which is the shortest path. So I'm sure by common sense, if we look at, we will be able to trace that shortest path. So the shortest path here is A to B, B to D, D to E. So a total distance of 1 plus 2 plus 2, that is equal to 5. So this is the shortest path when I draw, if I want to show. So this is the shortest path of this particular graph from A to E. Right. Similarly, I can find shortest path from any node to any node. Of course, some node may not be reachable in certain paths in case of directed, but most cases, yeah. So that is a shortest path. So given a graph, shortest path. How to do the algorithm? We have the Dijkstra's algorithm to find this. We will see that in the next video. Now, minimal spanning tree is another. We are doing it together so that we don't have confusions. So what is a minimal spanning tree? So again, it is on a directed weighted graph. So it is a subset of all the edges in the graph that forms a tree that includes every vertex where the total weight of all the edges in the tree is minimized, meaning I'm going to connect all the vertices such that the total is minimum. Okay. So there are many edges, so connecting only those which make my tree, because resultant will be a tree, such that the distance is minimum. So both are different. So how to implement this? So this is in fact the algorithm. Here we will see. So what we are going to do is, let's just imagine this as a collected number of nodes. That means just forget for a moment the edges A, B, C, D, E. That is called actually a forest because each is a tree by itself. You look at a node. So let's imagine A, B, C, D, E. So what we are going to look is the algorithm of what we are going to do. Minimum spanning tree, it is called Kurska's minimum spanning tree algorithm. How it works is we are going to select the edges having the least value. So for example, here there are two edges, right? A to B and C to E. So we select the one minimum. Let's take this A and B. So I connect that edge A to B. When I connect, if it forms a loop means a close-up, then we will ignore that. Then we select the next one. So this is the first one collected. So we take this first, then we connect. No loop is formed, so this is fine. Next is again A, so we connect this to, no loop is formed. Then next is, so ones are over, then we take the list 2. I can pick any 2. Let me take this one. So I connected this, that is D to C. So I have connected this. Now next, suppose what happens if I pick this now. So if I pick and connect this, is going to form a loop. That means a closed circle. So I'm going to ignore that. So this will not be connected. I will ignore this. And have I connected all the nodes? No. I have connected this two. I've connected this two. So these two are not connected. So I pick up this, the next least. So that is this, and connect. So now if I look, I have connected all the nodes and the length is minimum. So if I add up 2 plus 1 3, 3 plus 2 5, plus 1 6. So minimal spanning tree. So this is one minimal spanning tree. Similarly, suppose if I had ignored this 2 and picked up this 2, okay, it's also possible. Instead of this, if I pick up this, I can also get with this, this and this. That also is possible. So minimal spanning tree can be different in different cases, but shortest path is in most cases is unique because unless the distance is same between two. So do not confuse between the two shortest path, minimal spanning tree. Minimal spanning tree is connecting all the vertices such that the, the total weight is the least minimum. And here is shortest distance from one node to the other. We will see in the next algorithm how to implement this both. So for shortest path, we have Dijkstra's algorithm, and for minimum spanning tree, we have Urska's algorithm. We will see one by one in the next video.